Hello students, let us see a new problem on the directional derivative. The question is, find the directional derivative of 5 x square y plus y square z plus z square x square at point 1 to 1 in the direction of the normal to the surface x square plus y square minus z square x equals to c at point 1, 1 and 1, right? Okay. First, we need to understand what we have to calculate here. Okay. So we have to calculate the directional derivative of 5, right? So that means this is our phi function and the direction is given direction of the normal to the surface. Okay. So जो भी the direction is n cap of this surface, right? At point 1, 1, 1. So let us see how can we do this, right? Okay, so directional derivative is equals to gradient of 5 into a cap. What is a cap here? A cap is a bar upon modulus of a bar, right? Now here 5 is x square y plus y square z plus z square x square. So how can we define the gradient of 5? Gradient of 5 is del phi by del x I plus del phi by del y j plus del phi by del z k. So this implies gradient of 5. What is del phi by del x? That means 5 ka derivative with respect to x. So it is 2xy plus 2z square x I, right? So x square ka derivative is 2x, y treated as a constant. This is independent of x, that means derivative is 0, and the derivative of z square into x square is 2x z square, right? Iota plus derivative with respect to y partial. Okay, so it is x square, y ka derivative is 1 plus 2yz and the derivative is 0 there. So j plus with respect to z now, del phi by del z here. So this is 0 because it is independent of z. It is y square plus 2z x square. Now we need to calculate gradient of 5 at the point the given 1 to 1, 1 to 1. So x ka value is 1, y ka value is 2. So it is 4 plus 2 into 2, 2 into 1 ka square into 1. So it is 2, correct? Iota plus x square is 1 plus y into z is 2 into 2 4 j plus y square is 4 plus 2 k. So it is 6i plus 5j plus 6k, right? So gradient of 5 is 6i plus 5j plus 6k. Now we need to calculate the direction. But first of all, what is the direction is given here? It is normal to the surface x square plus y square minus z square x is equals to c. So first of all, s is here. S is x square plus y square minus z square x. Correct. This is our surface. Now we need to calculate the normal to the surface. That means, what is the normal? N cap is gradient of S upon modulus of gradient of S, right? Okay, so gradient of S. So gradient of, what is S? X square plus Y square minus Z square X. So it is del by del X of X square plus Y square minus Z square X iota plus del by del Y of X square plus Y square minus Z square X J plus del by del Z of X square plus Y square minus Z square X, right? So partial derivative with respect to X, this is 2X minus Z square iota plus X square का derivative is 0, Y square is 2Y minus, this is 0, that means it is only 2Y, right? 2Y J plus del by del Z of this, that means it is minus 2Z X K. So this is the gradient of S. Now we need to calculate the gradient of S at the point. Which point is given here? Let us see the question. The surface at Q 1, 1, 1. So let us put the values. 1, 1, 1. That means X ka value is 1, Y ka value is 1 and Z ka value is 1. So it is 2 minus 1I plus 2J minus 2K. So basically it is iota plus 2J minus 2K. Correct? So gradient of S is equals to I plus 2J minus 2K. Modulus of gradient of S is equals to square root of 1 square plus 2 square plus minus 2 ka square. 4 plus 4, 8 plus 1, 9. So it is 8. So N cap is gradient of S upon modulus of gradient of S. So this is 1 upon 3 iota plus 2J minus 2K. Right? So basically A cap is just a N cap, right? So A cap is equals to N cap is equals to 1 by 3 I plus 2J minus 2K, right? So therefore directional derivative, what is the formula? Gradient of phi into A cap. So what is gradient of 5? We have already calculated. What is that gradient of 5? 6i plus 5j plus 6k. 6i plus 5j plus 6k into dot product with A cap. So it is I plus 2j minus 2k divided by 3. So it is 6 into 1, 6, 10 and minus 12 divided by 3. So 16 minus 12 is 4 by 3. So this implies the directional derivative is 4 by 3 for this given problem. I hope you understood. Thank you.